All right, so we've now spent a few days using this new method for solving any quadratic equation. That new method, of course, is to factor. But as we saw on the first day, there are sometimes some different ways to go about an equation. And sometimes different ways can be good. They might allow us to do something else, and quite honestly, they could be easier. But the point is that we want to begin to think about some of these other ways. And so that's the goal today. Basically, my first question to you is maybe it would make sense to skip making this equation equal 0. Why would it make sense to skip the equation equaling 0? Well, it just so happens that this equation is perfect. It's perfectly something squared. What do we mean something squared? Well, we mean x minus 5. You see, I can rewrite x squared minus 10x plus 25. I can rewrite that as x minus 5 squared. The reason I can do that is because it's got the look. It's got the look of the perfect squared trinomial. Now, the look is that half of that negative 10x, when squared, is going to come out to equal 25. Wait, what are we talking about here? Well, we're talking about kind of a number inside of a number. What was it again? Half of negative 10 squared. Half of negative 10, by the way, is the number negative 5. And what happens when you square that number? Yeah, you get 25. You see, if it has that look, if it has the look of a perfect square trinomial, then you can rewrite it. You can rewrite it as, in this case, x minus 5, the quantity squared, and then you can use kind of like a square root method. A square root method where you get the square root of 27. That doesn't actually simplify nicely. No, it doesn't simplify nicely, but I still do get plus or minus the square root of 27, and I can still add 5 to both sides. If you add 5 to both sides, you get 5 plus or minus the square root of 27. Oh, kind of a different type of answer. Well, I told you sometimes learning something new might help us to be able to solve something new. You're going to find out a little later that the kind of problem we just solved actually could not be factored. It couldn't be factored because the number wasn't perfect. I'm talking about the 27. But listen, PST. Can everything become a PST? Well, actually, it can, as long as you put in the perfect number. What's the perfect number? Well, it comes from half. It comes from half of that number squared. So half of 8, yeah, it's the number 4. Squared, it's the number 16. Wait a minute. I can just add 16 into this equation? Well, yeah, I can add 16 into this equation as long as I also add it to the other side. It's kind of like a seesaw. You have to keep it balanced. So I can add 16, thereby making this problem perfect. What do I mean making it perfect? I mean being able to rewrite it as x plus, what number am I going to put here? Am I going to put 8? No. I'm actually going to put the half number. Yeah, the number that gives us the 16. And so I put x plus 4. Now, this is a different kind of equation. It's not equal to 0. Instead, it's got a square root in it. And because it's got a square root in it, it's a different kind of equation that I can solve using a square root. And since I can solve it using a square root, I end up taking the square root of both sides. You get plus or minus, and it's another one of these kinds of problems. Like it doesn't really simplify. That's all right. You're going to learn that the kind of answer we're writing here is a special type of answer. I'll just share with you. It's called a conjugate. Not super important right at this second, but the point is that this is the types of answers that we can get now being able to solve a new type of quadratic problem using a method called completing the square. So can I complete the square for any equation, like something with the 61 in it? Honestly, even though this 61 is kind of a strange number, I'm not worried about it anyway, because it belongs on, well, it belongs on this side of the equation. So yeah, let's move 61. That's not really the number that I need to think about when it comes to completing the square. Okay, what I really need to do is think about what number I'm going to put on the left side of the equation. So yeah, 61, you've just turned into negative 61, so that I can think about, well, that perfect number. How do we get that perfect number? That's right, it's always half of the x term, so half of negative 14 is truly negative 7, squared. Negative 7 squared, right, it's positive 49. So that's the number that I'm going to add into the equation. Wait, what's that you say? Yeah, if I'm going to add 49 to one side of the equation, I have to still add it to the other side of the equation. That's right, I have to keep it balanced. So when I put 49 on the left side of the equation, and I put on the right side of the equation, it allows me to rewrite the equation in that perfect squared form. What do we mean, the perfect squared form? Well, it's always going to be x, and then your half number. Your half number was negative 7, and then the whole quantity squared. It's always going to be x, the half number, squared. What's the new number that I get on the right side of the equation? Yeah, I get a new number over here. I get negative 12. So now the equation has, has been completed. We've completed the square. And that allows me to get ready to finish solving the equation. Now, solving the equation is going to involve a square root, where I can actually take the square root of both sides. Yes, it cancels with the square, and that leaves me with just x minus 7. But over here on the right side, I'm thinking about trying to take the square root of a negative number. That's right, another imaginary problem. So how does this work? You're going to pull out the negative as the letter I. And yeah, you can actually split up the number 12. You can split it up into 4 and 3. Remember, 4 is that perfect number that also gets to come out. Of course, the square root of 4 comes out as the number 2. So we end up with I2 root 3. What did we forget? Yeah, the plus or minus. So actually, I have plus or minus I2 root 3. And then this minus 7 that we have here is going to get added to both sides of the equation. And before I run out of space here, I'm going to end up with my final answer of being 7 plus or minus I 2 root 3. Method called completing the square. Now, completing the square is when you add in this perfect number. Can I just do that? Yeah. It's going to be half. It's going to be half of that x term squared. It always has two parts to it, half, then squared. But I can do this as long as I add it to both sides. Let's slow down just a hair here. First thing is you want to realize that it's kind of like I'm missing a number. And since I'm missing a number, I'm going to make a spot for it, right? Yeah, I need like some number in here. It's missing that perfect number. So I have a little spot for it, but I'm also making a spot on the other side because I'm going to have to, whatever I do to one side, I got to do it to the other. Half. Half of 4. Yep, 2. Squared. It's always half of that number squared. The perfect number that this equation is missing is a 4. Add it in. Make sure you add it to both sides. That's how this works. Why did I do this? Because now I can rewrite this side of the equation as something squared. By the way, the other side of the equation becomes 7. What do we mean something squared? We mean x plus 2. The number that you put there is always going to be the half number. Now, What's going on here? Am I just kind of like changing the problem? Well, not really, actually. All I'm doing is making it into a different form. It's still the same equation. It's still the original equation. But as soon as I put that 4 in there, sort of that missing perfect number, it allows me to use this square root strategy where I can take the square root of both sides. When you take the square root of both sides, you get plus or minus the square root of 7, another kind of imperfect number. That's okay. That's sort of how this works. It works for imperfect numbers. Subtract 2 from both sides to kind of finish the problem, and you get your x equals negative 2 plus or minus the square root of 7. Just a little by the way, that still is two numbers. It's not negative 2 and square root of 7. It's negative 2 plus the square root of 7, and it's negative 2 minus the square root of 7. Normally we don't split it up like that, but just so you can see, it does represent two separate numbers. Both would be decimals, but we're not worried about that. We want to see that square root. What do you think? Can you make a space? What I've found is that if I do this, then you can do it. But you do this. You put a little space. It's always going to work this way. The number that you add in is going to end up at the end of the equation, and it's also going to get added to the other side of the equation. So, what do you think? Half of 2 is 1 squared. It's always half that number squared. That's the number that you want to put up here. And so you should be putting the number 1. If you're going to add it to one side, you got to add it to the other side. We end up with the ability to write this as something squared. What's squared? X plus, not 2, but 1. And now when you take the square root of both sides, you get, we actually end up with plus or minus 6. It actually square roots nicely. Okay, cool. So when I subtract 1 from both sides, we'll subtract 1 from 6, and we'll subtract 1 from negative 6. Pretty sure that gives you 5 and negative 7. This is called completing the square. It's pretty snazzy because it allows you to, solve a problem that perhaps might not be able to be solved because it's going to involve some not so nice numbers. And the truth is, it's part of algebra. Realizing it's just another method. It's another method. But you have to realize that if it's another method, you have to realize what the first method was. So here we've got our little alien guy. He says 2. Okay, now deep breath, and sometimes we just need to be able to do this one way. Okay, and if you're looking at x squared minus 2x minus 5 minus 15, and you're saying, Miss Naylor, it doesn't seem like it's missing any numbers. No, it's not. Nobody said it was missing any numbers. It actually looks like this thing can be straight up factored. Two numbers that multiply to be negative 15 and add to be negative 2. We would have solved a problem like this on the first day. So we're just kind of using good old factoring, just in case you're getting confused here. Nothing's wrong. In fact, everything's right. We end up with a nice little 5 and a negative 3. Now, to be honest, that's probably the method I would have used for that problem. Okay? But there is another method. It's called completing the square. Now, completing the square means that I need to make space for some number. And you haven't seen this yet, but the number that's already there, which, by the way, it's not really the perfect number, just give it the boot. kick it over to the other side. You see, if that 15 had been on the other side in the first place, well then our equation would have looked like it was a little more ready for this thing called completing the square, where you basically put in the perfect number. What number? Half of this number, half of this number squared. Okay, you don't have to write all that down if you don't want, but I want you to know why we're going to put the number 1 here. That means you have to put it on the other side, and now the problem has been, well, it's been made perfect. What do we mean it's been made perfect? Well, just putting that number 1 there allows me to write this as something squared. Now, kids, be careful. Is it going to be plus 1? Not plus 1, minus 1. That way, it still works out to be negative 2x. Take the square root of both sides, right? You get plus or minus 4. And when you add 1 to plus or minus 4, you're either going to get 5 or you're going to get negative 3. Oh, the same answers that we found in the first method. Okay, now, remember, we want to learn new things. The new thing today is completing the square. It is nice for problems, especially that don't have perfect numbers. The last problem we just did here with the little alien guy, yeah, I mean, it probably is more easily solved the first way. But the point here is that we end up with the ability to solve it 2 ways. And now you're ready to try the homework.